Okay, we're going to talk about the parabola today in chapter 8.2. So we've got this really long definition. So I'll read it to you and then we'll draw a picture of kind of what's going on. So a parabola is a set of all points in a plane that are equidistant from a fixed line called the directrix and equidistant from a fixed point called the focus. The line through the focus and perpendicular to the directrix is the axis of symmetry. The vertex of the parabola is located at the midpoint between the directrix and the focus along the axis of symmetry. So a lot of words here. Let's put it to a picture here. So let's say I start with some parabola. So I've got this parabola here. Okay. Now we know from past experience that the item that divides that in half is called the axis of symmetry. So that's the axis of symmetry. Okay. On the parabola and at the axis of symmetry is the vertex. So right here, you got what's called the vertex. Okay, at some point on this, okay, we know that it said that the vertex is halfway between the focus. So let's say this is the focus and the directrix. So that's a line out here. Directrix. Okay. So the definition of a parabola says that the distance from the parabola to the focus is the same as from the parabola to the directrix. So this distance has to be the same as this distance. Why doesn't it look the same on my picture? Well, because I'm not an artist and I'm not perfect, but they should be the same. Okay. We also know that the axis symmetry and directrix are perpendicular, so they make a 90-degree angle. The distance from the focus to the vertex is the same as from the vertex to the directrix. And we also have another item that wasn't in the wording, but is really, really helpful. Okay, it's, let me figure out what color I want to use here. Let's just use black here. So if I take a point here on the parabola, go through the focus to the other side, and those are that's perpendicular to the axis of symmetry, this line is called the lattice rectum. Okay, and again, this length has to be the same as this length. Okay, and that's a very, very important a measurement to have, especially because it helps you realize where that focus is. Okay, so that's called the lattice rectum. Also, I label it as LR throughout this lesson. Okay, and this distance right here we call P, but it's also the same as this distance, which is also P, and you'll see that on some of the handouts and stuff that you'll be getting. Okay, so I do have a handout for this lecture. It's on the website, you can print off, and this is one of the charts that is on this handout. Okay, so print that off so that you don't have to write all this stuff down. So we kind of just talked a little bit about these pictures down here. Okay, so I can have two items, and again, this is around the origin for this one. So at the origin here. Okay, so my parabola can open in two directions. It can open sideways, meaning left or right, or it can open up or down. Now we've really talked a lot about y equals x squared being a parabola. And when we talked about that, we said it opens up or down, depending on the sign of x. So we're just changing that a little bit down here on this right column. Okay, I'm just putting x squared equals 4p. Now again, P is the distance from the vertex to the focus. If you look down at the picture here, okay, P is this distance right here. Okay, so 4P. So then it goes to the vertex at 0, 0, the focus at 0P or P0, depending on which way it opens up. You got the axis of symmetry, which in this case is some axis. You can tell if it opens right or left. It always opens in the direction of your focus. So if you know what the vertex is, you know what the focus is, you should know which way it opens. Okay, so you'll be able to use this through your suggested problems and on the homework quiz, but really get familiar with these concepts here. One tool that may be used in help graphing a parabola is called the latus rectum. We talked about that. This is a segment connecting the parabola through the focus. So if I just look at this picture right up here, if I draw a line from the focus or through the focus in the parabola, that right there is called the latus rectum or LR. How do you find the LR? Well, there's a couple different ways, but the easiest way would be that LR equals 4 times the absolute value of P. So if you know what P is, then you should know what the LR is too. Okay, so let's try some examples here. Find the focus and directrix of a parabola whose equation is y squared equals 8x. Okay, so that's going to be in the form y squared equals 4px. Why do I know it's that one? Well, simply because it's got a y squared in it. So it's either y squared or x squared. So 4p has to be the same as 8. So we'll simply say that 4p equals 8, making p equal 2. So if I start graphing this out here, is it going to open up, down, or left, right? Well, because it's y squared, that tells me that we haven't really dealt with y squared yet. So it's going to open left or right because we really haven't dealt with those before. Okay, so here's my vertex. Okay, it's 0, 0. And it's going to open up left or right. If you look at that sheet, it says that the focus is at P, 0. Okay, so P is 2. So we'll have 2, 0. So 1, 2, 0. So it's opening up in this direction. Okay. So now I need to know, what is the LR? How wide or narrow is this graph? Well, remember, LR is 4 absolute value of P, which happens to be 8, which is this number right here. Really, when you find the P value, you're also finding the LR too. So from this focus, I'll go up 4, and I'll go down 4, put a dot, and then there's my parabola. I also could put the directrix on here, which is the same distance this way. So there's the directrix. So what does that tell me? That tells me that if I choose, let's just choose this point on the LR. This distance is how much? Is 4. And this distance is also 4. Okay. So the distance from any point from the focus to the directrix is the same. Okay. And that's how you graph a parabola around the origin. Okay, determine the focus, directrix, length, latus rectum, and graph. So there's a few things we want. We want the vertex, the P value. We want the focus. Let's go ahead and put the directrix and the LR. So those are the things that you're going to want to look for before you get going on the graph. Okay, so I've got an x squared here. So that says x squared equals 4p y. So negative 12 and 4p have to be the same thing. So negative 12 equals 4p. So p is going to be minus 3. So we'll put a minus 3 over there. Okay, the vertex is at 0, 0. That's all we're really dealing with right now. And you'll see why this equation tells me it's 0, 0. We have a focus of, since this is x squared, that's going to open up or down. Since p is negative, it's going to open down. So my focus should be down somewhere. So that would be 0 minus 3. My directrix, since it's opening, we'll get rid of this one here. Since it's opening down at 0, 0, my directrix has to be somewhere up here. So that would be y equals 3, positive 3. Your directrix is always some kind of line, either x equals, y equals, something like that. You could rotate the parabola, but that's definitely above what we're looking for. And then LR. So LR equals 4 absolute value of p, which p is negative 3. So the absolute value of negative 3 is 3 times 4 is 12. So my LR is 12. So we kind of clear this out here and let's graph out what's going on. So let's start with the vertex is at 0, 0. My focus is at 0 minus 3. My directrix is at y equals 3. There's my horizontal line there. My LR is 12. So from this focus, I'm going to go 6 to the left. Of the focus and 6 to the right of the focus. And now I have this basic shape of what my parabola will look like. Again, any point on this parabola, let's say here, is the same distance from the focus as it is from the directrix. And maybe we'll do some something on MATLAB or something to kind of take a look at that. All right. So these are the key things that we need to be looking for on these type of problems. So find the equation of a parabola whose focus is at the point 0, half, and whose directrix is at y equals negative half, and graph. Well, we're going to kind of graph out what they give us. That way we can kind of see what we're looking at. So the focus is at 0, half. So 0, let's make this a 1. So 0, half. There's that. And the directrix is at y equals negative half. So here's my directrix here. Okay. Now, halfway between those 2 points is my vertex. So we've got vertex is at 0, 0. Okay. And we've got our p-value. The p-value is the distance from your vertex to your focus, which is a half. Okay. So I know that this is opening in this direction, okay, because it starts at the vertex, opens the direction of the focus. So that's going to be something y squared equals 4px. Okay, so I know what p is, so we'll just plug p in. So y squared equals 4 times a half x. So y squared equals 2x. So this also tells us one other thing. This tells us what LR is. And LR is 4 absolute value of p, which is 2. So if I cut this here through the focus, that is 2 units long, or 1 on the top and 1 on the bottom. So when I go to graph it, I want to graph that That way I can get exactly, how wide or narrow is this parabola going. Okay. Again, if you got questions while you're going through this, be a good idea to maybe write it in your notes or write it somewhere. That way you can ask me the next time we're in class together. This is the second part of your handout. And it talks about if it is not at the origin. So the center of my parabola is at some point HK. And we've used HK before. Okay, remember H goes with X and K goes with Y. We still have the opening up and opening down. Let's see, this is X squared, so that would be up or down. This one's Y squared, so that would be left or right. The vertex is H and K for both of them. Your focus will be different, okay? So if it's opening left or right, I've got to move the focus on that x-axis. So that's where I'm going to add P. With X squared, it's going to move the focus up and down, so that's why it's going with the Y. So P plus K in that case. Then your directrix, negative P plus H, so you're moving it in the left, right, and then negative P plus K, again moving it up, down, axis symmetry. And you can tell a lot of this will be intuitive once you get going on these type of problems. Okay, graph the parabola given the equation. Okay, so I give you here the general equation, and we need to put it into the standard equation. That way it's a little more user-friendly. Okay, so notice I've got a y squared and a y, so that tells me I'm going to have the y minus k squared equals 4p x minus h. So that's the form I'm looking to get it into. So I'm trying to get this term, this x minus k term here. So in order to do that, I need to move everything to the other side except what has y's. We've got y squared minus 6y, and then 2x minus 8. Now, in order to get this factored, we did this a little bit with the circles. In order to get this factored squared, we got to complete the square. So plus blank plus a blank. How do I know what goes in the blank? That's simply b divided by 2 squared. So you're going to take negative 6 divided by 2 and square it. So negative 6 divided by 2 is negative 3. Negative 3 squared is 9. And don't forget to add it to the other side as well. So then I can take these three terms on the left side and factor them. So that's factors of 9, that subtract, or that add to 6. That's 3 and 3. They're both the same and they're both negative. Again, you should know how to be factoring these kind of things. 2x plus 1. Now notice here, I don't, in my equation up here, I've got something outside of parentheses. So I need to put something outside of parentheses here. And notice the coefficient on x here is 1. So I'm just going to factor out this 2. So y minus 3 squared equals 2x plus a half. Okay? So this is your standard form. Okay, so again, I want to look for those key components here. Start with a vertex. The vertex is at HK, so H happens to be negative a half. It's the opposite of what it looks like inside of there. And then 3. Your P value, okay, remember this is the same as 4p, so 4p equals 2, so p is a half, so p is a half. You want your focus, okay, so it's y squared, so it's open left or right, so we want to add that p value to our y, sorry, to our x, because we're moving we're moving it in the x direction. So that's 1/2 plus -1/2, comma 3. So that's 0, 3. Our directrix will be x equals -p plus h. So that's x equals -1. And then our LR equals 2. Again, this right here helps you find out what the LR is. And then simply we got to graph all those things. Or graph enough to see what's going on. So we'll start here with our XY axis. Our vertex is at -1/2, 3. So there's 1, 2, 1, 2, 3. So -1/2, 3. We've got our directrix at -1. We've got our focus at 0, 3. And we've got our LR of 2. So that's 1 down and 1 up. So I've got this parabola sitting in right here. Okay. Now some other things that the book or maybe a test or something might ask you for is this point and this point, which those 2 points I hope you know are the y-intercepts. And that is when x is 0. And then there'll be a point, you know, if this extends out here, there'll be a point here that is the x-intercept. And that is when y equals 0. Okay, so make sure you know how to find those points along with the others. So graph the parabola given the equation. So this is very similar to the one we just did, except now I've got x squared and x. So that means I've got x minus h squared equals 4p y minus k. Okay, so that also tells me that it's opening up and down. Up or down, not both. Okay. All right, so I'll get the x's on one side. I'll add the blank. And so you got to move that to the other side and then -7 to the other side. So you get 8y plus 7 plus blank. Okay, so we'll take b divided by 2 squared. So that's -2 divided by 2 is -1. -1 squared is 1. 1. So then take these 3 and factor them. So that's x minus 1 squared equals 8y plus 8. And then we'll factor out the 8 out of that right side. So it's x minus 1 squared equals 8y plus 1. And we go through our key things. So vertex, P, focus, directrix, and LR. Okay, so the vertex, that's HK. So in this case, that's 1 minus 1. P, I got 8 equals 4P. 8 equals 4P. So it's like P is 2. Go ahead and put down your LR here is 8. And change that to the absolute value there. Focus. So because it's opening up or down, we'll move our focus in the y direction. So we just take our P and add it to the y there. So I'll get 1, 1 for the focus. And the directrix in this case is y equals -p plus y. So -2 plus -1 is -3. Okay. Again, all 5 of those you can see from that handout or that printout that's on the website. So my vertex is at 1, minus 1. My focus is at 1, 1. Leaving my directrix at negative y equals negative 3. Okay, so here I'm going to open up in this case. So use your LR and go to the right 4 of the focus and to the left 4 of your focus. And then kind of connect it with a curve. Try not to do a V, because remember V is an absolute value there. So kind of curve it around. And that's how you graph. So we went from general equations to a graph. What happens if I go from a graph to a general equation? So find the equation of a parabola whose vertex is located at the point 2, negative 3, and whose focus is located at 5, 3. So kind of doing this just a little bit backwards, let's take a look at the graph. So I'm at 2, negative 3 for my vertex, and 5, negative 3 for the focus. So my graph's opening up something like this. And I know this value right here to be P, and that's just 1, 2, 3. So P is 3. Okay, since it's opening to the right, that would lead me to believe, and it's not at the origin, so I've got y minus k squared equals 4px minus h. Okay, that's the basic equation that I'm going to use. Well, I know what h and k are. That's simply the vertex. And we figured out what p was, so then we'll just plug them in. So I've got y minus negative 3, so plus 3 squared equals 4 times 3 x minus 2. So it's y plus 3 squared equals 12 x minus 2. Okay. Now this is the standard form. Okay, and sometimes they'll ask you for a general form. Now general form is a little less user-friendly. And it's when everything is on one side as single terms, non-fractional coefficients, and it's set equal to 0. Okay, so in order to do that, we just got to take this and multiply it out. So that's y plus 3 equals, and then distribute that out. So 12x minus 24. So this is what? Y squared plus 6x plus 9 equals 12x minus 24. So then we're going to move this, and this is a y there. We're going to move the 12 to the other side and the 24 to the other side. So in the end, I'll get y squared plus 6y minus 12x plus 33 equals 0. And again, if it doesn't say, just leave it in this form right here, this standard form. That's super user-friendly. Okay, if you give that to me, I know exactly what we're talking about. Okay? If you give this to me, I may have an idea, but I still want to, find the vertex and find the p-value and those kind of things to make it a little more understandable. This one down here just looks nicer. It's easier to program into computers and that kind of stuff. Okay, let's get into maybe some word problems, some application problems of how this is really used. So a satellite dish is 24 feet in diameter at its opening and 5 feet deep in its center. Where should the receiver be placed? Okay, first thing we need to do is talk about a satellite dish or something like that. So let's say I've got this satellite dish here on my house. Okay, and it's got a curve here, and then it's got this arm that comes out with maybe like a little box on it right here. Right. Okay. So what happens here? And let me move this down just a little bit. Okay, what happens is that from out some signals come in from outer space, right? That the TV company or whatever satellite company is sending. And what happens is each one of those, no matter where it hits here, gets bounced off into a fixed point here on, I could even come in here and it gets bounced in. Come here, not that I do come from down there, but it comes in at this direction and they all get bounced to this one point. Now this is a very specific point related to the curve of that dish. So if maybe I extend that dish on, okay, this point happens to be the focus, okay? So the focus is exactly where this receiver is going to go. So that's what I need to be looking for, okay? So if I draw the picture of what they're giving me here. So I've got a satellite dish that is 24 feet in diameter at its opening. So I've got some ginormous satellite dish here. So from here, there to there is 24 feet. Okay. And it's 5 feet deep at its center. So from here to here is 5 feet. Okay. Where's the receiver going to be placed? Well, it's going to be placed at the focus. But I don't know that this point is the focus. I don't know. If I knew that this 24 feet was the latus rectum, then I would know that that's the focus, but I don't know. So what I'm going to do is I'm going to put it onto the graph at 0, 0, and look at the equation. So since it's opening to the left or to the right, that would be y squared equals 4px. And I can use this one since it's at the origin, hence why I put it at the origin. You could put it, anywhere on the graph that you wanted, or you could put it opening up or down, but you're just going to have to use some different things with it. Okay, so I don't know what P is. That's what I'm looking for. I'm looking for, where is this focus? Let's say it's out here. I'm looking for this distance between the vertex and the focus. So since I don't know what P is, I have to know an X or a Y. Well, a lot of you would probably say that this point right here would be a good one, this 5, 0. Well, that point's not on my parabola. Okay, here, this black part's my parabola right here. I need a point on there. Okay, so what about this point right here? Or some of you would say 0, 0. Yes, 0, 0 is on there, but when you plug 0, 0 in for X and Y, everything cancels out. So that doesn't help you at all. So let's choose this point up here. This is at what, 5, and then go up 12. So that's 12 and that's 12. So this ordered pair is 5, 12. So we'll put 12 squared equals 4p times 5. So that's 144 equals 20p. So P is going to be 7.2. So now I know that from the center out to this focus is 7.2 feet. So that's where the installer, or whoever's putting this in, needs to be putting that receiver to optimize, to get the best quality of picture or whatever they're transmitting. He could put it here and he'll get some, but he's not going to get all of the reflections off of that satellite. Okay. If the parabolic sound dish and the sideline crew is holding, it has a 2-foot diameter at the opening, and the microphone is located 6 inches from the vertex, find the equation that governs the center cross section of the parabolic sound dish. Okay. So we can do this one a couple different ways. So I've got a 2-foot sound dish here. And I've got this microphone that's 2 feet across, and the microphone is located 6 inches away from the center, or a 1/2 foot. Now, I don't know from the writing here, I don't know if the microphone's here or if it's in here or if it's out here. So that's kind of one, we don't want to assume from this writing that the microphone's on this, that this is the LR. So that's one thing that we're going to have to figure out. So again, just like the last one, we're going to map it onto a coordinate system here. So again, opening to the right or to the left or right. So that's y squared equals 4px. Now in this case, I do know what p is, okay, because it tells me the microphone is located 6 inches away. The microphone is kind of like the receiver. Well, it is a sort of receiver. It receives sound. So it's got to go at that focus. So y squared equals 4 times a half x. So that's y squared equals 2x. There's your equation that governs the sound dish. Well, look here. Remember what this finds. This finds your LR. And it found that the LR is 2. So if I come back over here to my picture, this was 2, which tells me that that's the LR, which tells me that that right there is where the focus is. But you can't assume at the original that that's where the focus is. Okay, so that wraps up 8.2. Here's your suggested problems. Again, look at them, please. And if you got questions over them, come in before or after school, and we'll get your questions answered. Again, thanks for watching.